With number 9, we get into our section that has to do with radicals. It has a lot of directions. We can add, subtract, or multiply, but one of the most important things is give it in its simplest radical form. It means you have to simplify everything down, okay? Well, my first one, I'm just looking inside the radical at 243. Again, if you're watching this and you don't have me as a teacher, or even if you do, you can break these numbers down a lot of different ways. And it's always going to be a correct answer because every single number has a unique prime factorization. And that's what we're doing is we're factoring it out. But if you have me, you know I'm a simple man. I try to use 2s and 5s. And then after that, I use 3s. I don't try to break 243 down immediately into complicated stuff. I use 2s, 5s, 3s if I have to, stuff like that. Well, 2 and 5 aren't going to work. This isn't an even number, and it's not ending in a 5 or 0. So I'm going to try 3. When I do 243 divided by 3, I see that it does work. It breaks into 3 and 81. Here's where you can shortcut the problem. 81 is a perfect square. You could just square root it and pull it out front. But I know a lot of people don't like to do that. A lot of people just like to continue the process. But most people know their times tables that 81 can break down into 9 and 9. Again, you can stop here because you see the pair of 9s, but just to be safe, we finish it out. It breaks down into 3 and 3 and 3 and 3. Also, our variable will break down. X to the 4th power is just x times x times x times x. So we're looking for any sort of pair we can find to pull out front. Well, there's a pair of 3s, and there's a pair of 3s. Now be careful because we left one behind. That 3 is going to come out. That 3 is going to come out. There's a pair of x's. There's a pair of x's. And nothing got left behind with our variable. Okay, anything left behind stays under the radical. Well, when this pair of 3s come together, they pull out front, they slam into whatever else was there. So they multiply by it. 3 times 3 is 9, times 3 again is 27. X times x is x squared. Please do not forget that we left something behind. It goes in the radical. And that would be our answer. That is in simplest form. Okay? Number 10 is a similar problem. We're going to start by breaking down 192. Again, you could come up with some bigger numbers that go into 192, but I'm a simple man. If it's an even number, I'm going to just divide it by 2 if I don't type in the wrong thing. I'm going to divide it by 2, and I'm going to get 96. 2 and 96. I'm not great with my times tables. Maybe you are, but I know that 96 is even, meaning I can just divide by 2 again and get 48. I can divide that by 2 again. So I can just keep doing this until I start getting numbers that are small. So 96 is gonna break down into 2 and 48, which is 2 and 24, which is 2 and 12, which is 2 and 6, which is 2 and 3. Again, that was much more steps than it was required, but it kept it nice, easy numbers. It was just 2s. My x to the 5th power can break down into x times x times x times x times x. It's 5 x's, okay? Now I'm looking for pairs. Don't forget this negative sign out front. It started out there, it's got to be there. I got a pair of 2s that are going to come out. Another pair of 2s that are going to come out. Another pair of 2s that are going to come out. And then a 3 that I left behind. Got a pair of x's that are going to come out. Pair of x's that are going to come out, and I left an x behind this time. At the end of the problem, everything that you or every little piece you broke down should have some sort of indication on it, whether you're pulling it out or whether you're leaving it in. Well, this is a negative sign, so when I slam a 2 into it, it becomes a -2. When I multiply that by -2, or by +2, it's a -4. And I multiply by 2 again, I get -8 as my number out front. X and x becomes x squared. Very similar to the last problem. But now, under my square root, I have a 3x left over. A 3x left over. Okay? Number 11 is where we move on into actual operations with radicals. This is a subtraction problem. And to do a subtraction problem, we first have to simplify to see if we have like terms. Well, square root of 5 and square root of 5 are already simplified. And they are like terms. Having the same thing under the radical makes these like terms. So we can combine them. And when we combine them, it's just like they're variables. We just work with the numbers out front. This is a -1 out front. So when we combine them, we should get -4 square roots of 5. Okay, so you combine it just like it was a variable, just like those square root of 5s, just like x's or y's or something like that. You just work with the numbers out front. Okay?